Hello, good morning. Am I audible? Yes, Amisha, Aditya.
Yes, sir.
Yes,
Okay. Okay, so let's start. Mm, In the previous lecture, we have solved one sample problem based on root locus method. Okay, so simple problem we have solved. So take now another problem. Write down the problem. Change the root locus for change the root locus for the system given its g of s into h of s will be given by k upon s into s square plus twice s plus 2. So here in this problem, the complex roots are present. Okay, write down the solution. We have to sketch the root locus for even system and also comment on the stability. So tell me the step number one. कहाँ से स्टार्ट करोगे? Yes, anybody? So write down the for first step is that our root locus is always symmetrical about the real axis, so we can neglect it. Then in the second step, we just find the total number of poles and zeros which are present in our transfer function. So here k upon s into s square plus twice s plus 2. So how many number of poles and zeros are present in this given transfer function? Please tell me number of poles and number of zeros. So how many branches are present? N represents the number of branches of root locus. कितने पोल्स और कितने जीरोज है ये ट्रांसफर फंक्शन में we just compare this transfer function with standard form of pole zero form representation of transfer function. We have seen in the previous unit, न्यूमरेटर टर्म जो रहेंगी वो रहेंगे जीरो, डिनोमिनेटर टर्म रिप्रेजेंट्स द पोल्स. Nobody? Okay. So here it consisting of P is equal to 3, Z is equal to 0. So therefore, as first condition is satisfied, P is greater than Z. So therefore, P number of branches must be equal to N is equal to P is equal to N is equal to P and must be equal to 3. So this will be our step number 1. Then we also locate the location of the pole. So at S is first pole it as origin. Okay, so this is S. So one pole it as origin at S is equal to 0. Then S square plus twice S plus 2. So these are the complex pole. Okay, and its value will be, if you find out, it could be -1 plus J and -1 minus J. So these are the three poles present in the given transfer function. One pole at S is equal to 0, -1 plus J, -1 plus J. So this is the complex pair of the pole. So here in this problem, we are going to sketch the root locus. It consisting of complex pair of poles. So this will be our step number 2 or 1. Then later on, what will be the next step? Find the existence of root locus on real axis. Okay, so how to find it? So you just sketch a rough sketch of pole zero plot in the complex plane sigma plus j omega. So locate your roots. So first root is located at origin. So this is our first pole. Then these are the two complex poles, -1 plus j. So let's say here is my plus j, and somewhere here I got minus j. So this magnitude I can consider it is -1. This could be minus infinity. So one pole is located here, another pole is located here. So this is my pole zero plot representation. Okay, so we just give figure name to this also. Figure for pole zero plot. Okay, then how to find the existence of root locus on real axis? So you just divide your real axis into different sections. Okay, so I first consider up to this -1. Okay, so beyond this -1, I just divide this. This is my first section. Okay, so section 1. So in this, what is the sum of P plus Z beyond this line? So you have to consider only poles on the real axis. Okay, so here is P plus Z is 1. P plus Z is equal to 1, so which is odd. So therefore, this part is a part of root locus. Therefore, I have dark this line. Then after this line, again there is no pole or zero lie on the uh, real axis. So again I can consider the section at minus infinity. So during this section again P plus Z is 1. P plus Z for whole section is 1. So therefore this complete section is a part of root locus. So therefore I just dark this line. Okay, and above this line I just write down it is a part of root locus. So whole real axis is a part of root locus. So this is our tip number 2, existence of root locus on real axis. Do you have any doubt up to this? Then step number 3. Tell me the next step.
Asymptote.
Number of asymptote. Okay. तो asymptote कब प्रेजेंट रहेंगे? When there is a disturbance between P and Z. जब तक आपके P और Z इक्वल नहीं रहेंगे, उस केस के लिए नंबर ऑफ asymptote प्रेजेंट रहेंगे. जिस केस में number of poles is equal to number of zero, in that case there is no number of asymptote. So please remember, number of asymptotes are present for when P greater than Z or Z greater than P. ये दोनों केस के लिए नंबर ऑफ asymptote प्रेजेंट रहेंगे. Okay, so write down the formula. What is the formula? Theta is equal to twice q plus 1 into 180 divided by P minus Z, where this q is varies from 0, 1 up to P minus Z minus 1. So here in this case 0 to our P is 3, Z is 0 minus 1. That means q is varies from 0 to 2. That means you have to vary the value of q is 0, 1, 2. Okay, so determine the value of theta 1. When q is equal to 0, we will get theta 1. Q is equal to 1, we will get theta 2. और Q is equal to 2, we will get theta 3. जब तक तीन एंगल रहेंगे at that time your theta 1, theta 2 values are remain same. Okay, once you calculate you can directly write down 180 by 3, it would be 60. Then second आएगा आपका 240. Sorry, you can just substitute the value. Q is equal to 1, 2 plus 1, 3. That means it could be 540 by 3. It could be 180. For Q is equal to 2, theta 3, Q is equal to 2, 2, 4, 5. So 5 into 180 divided by 3. So it could be 300. So theta 1, theta 2, theta 3 are 60, 180, 300. Okay. Then next step, determine centroid. What is centroid? Centroid क्या रहता है? Centroid is the point where all these asymptotes angles are meet together on the real axis. That is called as the centroid. Okay, so write down the formula of centroid. Sigma will be given by summation of real part of the poles minus summation of real part of the zero divided by P minus Z. So sigma is equal to summation of real part. तो पहला पोल का रियल पार्ट 0, सेकंड पोल का रियल पार्ट -1, थर्ड पोल का रियल पार्ट -1, देन इमेजिनरी पार्ट माइनस, ये ब्रैकेट में ले लो, इसका रियल इमेजिनरी पार्ट 0, इमेजिनरी पार्ट 1 -1. ओके, सॉरी 0 है नहीं, therefore it could be 0 divided by P minus Z. So P minus 0, so it could be -2 by 3. Sigma could be -2 by 3. So what could be the value of -2 by 3? It could be minus 0.66. So this could be your centroid. Okay, so that means We can locate our centroid in the complex plane sigma. Here j omega. Here is one pole. These are another pole. Let's say this could be -1. So here is minus 0.66 equal to sigma. Here is your centroid. So your first angle could be, here is theta1, this could be theta2, and this could be theta3. So theta1 is 60, theta2 is 180, and theta3 is 300. So this is the location of your centroid, that is sigma, and these are the angle of asymptote. So can you tell me how your root locus branches are starting and terminating from this? You have three poles. This is pole 1, this is pole 2, and this could be pole 3. So three branches, n is equal to 3. Okay. So root locus branches are always starting at open loop poles and terminating at open loop zeros if present. If not, it may terminate on infinity. So here in this case, your two branches will be starting at complex pole and one branch will be starting at pole at origin, and then it can terminating. So that means this pole branch may terminate via theta1, this pole branch originating, so this may terminate with to theta3, and the branch root locus branch starting at this pole, it may terminating to theta2, like this. Okay, so that we will see. Then next step, step number 6, breaking point. So is there is an existence of breaking point in this case? Can you tell me? कोई two consecutive poles है क्या यहाँ पर poles या zero on the real axis when there is existence of breaking or breakaway point? Okay, so for this problem there is no, we just write down, there is no existence of break in or breakaway point. तो अननेसेसरी आप आपका बर्डन एग्जाम में नहीं करना है, ठीक है, बिकॉज आप लोग कैलकुलेट करोगे आपको पॉइंट भी मिलेंगे बट विच इज अनयूजफुल हियर. So you just you can directly write down there is no existence of breaking or breakaway point. तो क्यों नहीं है? So there is no consecutive poles exist on the real axis. Okay, so therefore there is no existence of breakaway point या फिर two consecutive zero भी नहीं है. So that's why this rule is not applicable here in this, or particularly for this example. So go for next step. So next step है intersection with imaginary axis. Intersection with imaginary axis. I have skipped one step, that is the determination of angle of aperture and departure. So that we will take at last step. Okay. So before this, that step will be there. Before that, we just determine it and go for last one. So which method is used to determine intersection with imaginary axis? How to determine? So here your G of S into H of S will be given by K upon S into S square plus twice S plus 2. Okay, so write down the characteristic equation 1 plus G of S into H of S, which is equal to 0. So here is 1 plus 1 plus K upon this term S into S square plus twice S plus 2, which is equal to 0. Simplify this, S into S is S cube plus twice S square plus twice S. Okay, so therefore multiply by this, तो ये आ जाएगा आपका S cube plus twice S square plus twice S plus K, which is equal to 0. So this could be your equation, a characteristic equation. So use the root harvest criteria here. S cube, S square, S raised to 1 and S raised to 0. So prepare the root array. So alternate coefficient S cube coefficient is 1. After that 1 के बाद में 2. No 1. S raised is first is 2. K. Complete this 2 into 2 4. 4 minus K. So this could be 4 minus K upon 2. This could be 0. So this into this divided to 0. So it could be K. So this is your root array. Okay, so we know that all the elements in the first column must be positive. So for that purpose, we have to assume the element corresponding to S raised to 0 is K. So value of K to be greater than 0 for system to be stable. Okay, then 4K, 4 minus K, so corresponding to S raised to 1. So elements we are getting 4 minus K upon 2. So that could be must be greater than equal to 0. Okay, so with this assumption, we will get the marginal value of K. Okay, so find the value of K marginal. So 4 minus K is equal to 0. So here K is equal to 4. So K marginal is equal to 4. Okay, then so this is the row corresponding to 0 or K marginal. ये रो के corresponding हमें K marginal मिला. So above that row, you can consider this row as auxiliary equation. Okay, then to write down the auxiliary equation. तो आ जाएगा your auxiliary equation will be given by 2s square plus k, which is equal to 0. So substitute the value of k marginal. So 2s square plus 4, which is equal to 0. So find the roots of this equation. So tell me the roots. S, so s square would be equal to -2. Okay, if you simplify this, so s square must be equal to, so s is equal to plus minus j 1.414 plus minus j 1.414. So these are the, so s is equal to plus minus j 1.414. So at this point, your root locus branches intersecting the imaginary axis. And this we have determined from the root array, that is from root locus method. Now the last step is to determination of एंगल ऑफ कॉम्प्लेक्स पोल के लिए कौन सा एंगल रहेगा? एंगल ऑफ डिपार्चर. Okay, and angle of departure is denoted by phi d. And what is the formula? Phi d will be given by 180 minus phi, or sometimes 180 minus angle of g of s into h of s. So when there is the existence of complex poles, at that time angle of departure is present, and when there is the existence of complex zero, at that time angle of arrival would be present. Okay, so how to determine the angle of departure for the complex poles? Okay, so that you can understand. So if you have the graph paper, then you can easily determine. Okay, so you just note down the process how to determine phi d. So these are your complex poles. You just sketch pole zero plot of your given problem. So one pole at origin, one pole at, write down this value, -1 plus j. This is your pair of complex poles. -1 minus j, like this. Now, how to determine angle of departure or arrival? For that purpose, what you have to do, आपके जितने भी कॉम्प्लेक्स पोल है, okay, so you just connect your one complex pole with all the other poles and zeros on the real axis. ओके, अभी यहाँ पर कितना है? यहाँ पर रियल एक्सिस के ऊपर सिंपली एक ही पोल है, तो देयरफॉर, और अपने पास में दो कॉम्प्लेक्स पोल्स है. सो ये पोल के लिए हम लोग फाई डी डिटरमाइन करेंगे, ये पोल के लिए भी फाई डी डिटरमाइन करेंगे. तो ये पोल के लिए डिटरमाइन किया तो उसका आप कॉम्प्लीमेंट्री एंगल जो भी रहेगा वो ये पोल के रहेगा. तो देयरफॉर वी जस्ट डिटरमाइन द फाई डी फॉर एनी वन कॉम्प्लेक्स पोल. ओके, और वो डिटरमाइन करने के लिए क्या करना है? एक कोई भी कॉम्प्लेक्स पोल आप कंसीडर करो, और वो पोल जितने भी रिमेनिंग पोल्स और जीरो रहेंगे आपके पोल जीरो प्लॉट में, उसको कनेक्ट कर दो बाय सिंपल स्ट्रेट लाइन. ओके, सो यू सी दिस, आई जस्ट कनेक्ट हियर. ये जो कॉम्प्लेक्स पोल है, इसको मैंने अभी अपने पास में कितने पोल्स है? पोल्स और जीरो अपार्ट फ्रॉम कॉम्प्लेक्स पोल, ये छोड़ दो, ये छोड़ दो, उसके बाद में ये एक ही पोल है. सो देयरफॉर इसको मैं ज्वाइन कर रहा हूँ. तो इन दिस वे ज्वाइन करो. अगर यहाँ पर रहता था, मैं यहाँ पर भी इसको एक स्ट्रेट लाइन से ज्वाइन करता, लेकिन है नहीं, है एक ही है, इसलिए ये लिया. तो दिस विल बी योर फर्स्ट स्टेप. ओके, जो पोल के लिए आपको अभी हम लोग डिटरमाइन कर रहे हैं फाई डी फॉर दिस -1 plus j. So you just write down here we are determining phi d for -1 plus j. ये पोल के लिए हम लोग phi d डिटरमाइन कर रहे हैं. तो इसके लिए जो phi d मिलेगा उसके अपोजिट साइन वाला phi d ये पोल के लिए रहेगा -1 minus j के लिए. So like this way we can determine and we have the formula. ओके, अगर आपने ये ग्राफ पेपर के ऊपर ड्रॉ किया रहता तो आप डायरेक्ट एंगल मेजर करके भी आपको phi d मिलेगा. Okay, so therefore you just write down here the formula The value of phi d is 180 minus phi, where this phi will be given by summation of phi p minus summation of phi z. So phi p phi z means the angle which is contributed by the poles and the angle which is contributed due to the zeros with respect to respective complex pole under consideration. Okay, so therefore, how to determine this phi value 180 minus अभी summation of phi p, यहाँ पर जीरो है नहीं, that means ये पार्ट में ये टर्म जीरो आ जाएगा. तो समेशन ऑफ फाई पी हमें डिटरमाइन करना है. तो ये एक ही पोल है, ये पोल के वजह से इसके ऊपर कितना एंगल कंट्रीब्यूट हो रहा है, सो दैट वी हैव टू डिटरमाइन. ओके, सो व्हाट इज समेशन ऑफ फाई पी. ओके, तो यहाँ पर अभी एक ही पोल है, सो देयरफॉर यहाँ पर आ जाएगा सिंपली फाई पी वन. समेशन ऑफ फाई पी में आ जाएगा angle contributed due to this pole with respect to this pole, so only one ही आ जाएगा. Okay, so therefore we just determine this. How to determine this phi p1? Okay, so can you determine this angle? So this angle is 90, and can you find the value of this angle? This length is, this point is -1, so this length is 1, as well as this length is also 1. So can you find this angle? This could be your phi p1 or say any angle phi. Then this will be your total phi p. So this total angle is phi p1 and we require phi p1 value. So phi p1 को हम लोग लिख सकते हैं 90 प्लस, इसको मैं एंगल देता हूँ 90 प्लस phi 1. We have to find the value of phi 1. So once you get the value of this phi, we can easily determine phi 1. Okay, so I will determine this angle phi 1, या फिर आप ऐसे ही कंसीडर कर सकते हो दिस, ये आ जाएगा 90 डिग्री. ओके, तो यहाँ पर आप ट्रिग्नोमेट्रिक फार्मूला अप्लाई करो phi 1. तो इसको लिख सकते हैं हम लोग 180 minus 90 plus phi 1 is what is tan theta. ओके, सो ये आ जाएगा tan इनवर्स ऑफ 1/1. If you apply trigonometric rule here, so it could be tan inverse of 1/1. Okay, so here 180 minus, so what is tan inverse of 1? Please calculate it. It could be 45, so therefore it could be 90 plus 45. Okay, so therefore it could be 180 minus 90 plus 45, so it could be 135. So 135, so 180 minus 135, how much? 180 minus 135, so it could be 45. So your value of phi d is plus 45. Here we have got, so we have got the value of phi d is plus 45 for -1 minus j. So similarly we can write down what is the angle contributed So phi d value for -1 minus j, as for -1 plus j के लिए plus 45, so phi d for -1 minus j is minus 45 because all are the complementary of each other. So therefore in this way you can directly take down. So here we have got minus 45 degree. Do we have any doubt in the calculation of phi d? As this is a simple problem, so that's why here we have directly taken out the calculation. So this 90 degree plus this angle. Okay. आप जब ग्राफ पेपर के ऊपर ड्रॉ करोगे एट द टाइम आपको डायरेक्ट मेजरमेंट से मिलेगा, या फिर यू कैन यूज द फार्मूला. यहाँ पर हमने सिंपली tan इनवर्स का फार्मूला अप्लाई कर दिया. तो दिस साइड इज 1, दिस साइड इज आल्सो 1. So this one, this one. So tan inverse of 1 by 1, that will give you phi 1. Okay, so that we have substituted here and we'll get the value of phi. So in this way we will get phi. Okay, so here we have finished all the steps. Now in the last step, you just sketch the root locus. Okay, so step by step you can sketch the root locus, how to note the value of phi d, and how will you sketch the root locus. Okay, so here is sigma j omega axis. Here is our one pole at origin. Then I can consider this point is corresponding to -1. So this is my one complex pole. This could be second complex pole. Okay, so write down their values. -1 minus j. This pole value is plus 1. Sorry, could be -1 minus j. Plus j. Yes, this could be -1 plus j. Okay, then next step. This is a part of root locus. Okay, and locate a centroid. Centroid कितना मिला था? Can you tell me? So somewhere here minus 0.66. That is minus 2 by 3. So इतना हमें centroid मिला. So this could be our centroid sigma. Then draw the angle. Angle of asymptotes. So one asymptote along 60 degree. Okay. So approximately I can draw. Whenever you are drawing on the graph paper, you can take the actual measurement. So here theta 1 is equal to 60 degree. Then theta 2 is along negative real axis. So here is my theta 2 is 180 degree and theta 3 is along 300. So somewhere here I can draw it like this. Here theta 3 is 300. So we have marked centroid. We have shown all the asymptotes. We have shown the existence of root locus on real axis. Okay. Then starting up the root locus branches. So we have n is equal to p is equal to 3. So how your root locus will be starting? So root locus branches are always start at open loop poles and terminates at open loop 0. If present, यहाँ पर 0 है नहीं, तो therefore पहले सिंपल वाला ले लेते हैं. एक रूट लोकस ब्रांच आपका ये पोल के ऊपर स्टार्ट होगा. ओके, तो at k is equal to 0, your root locus branch is originating at this pole. Okay, so and it may move like this. So therefore ये जो branch है, this branch may terminating to infinity, to this infinity via this theta 2. Theta 2 के through वो terminate हो जाएगी. That means this is your first root locus branch at different values of k. Okay, and it may terminating to theta 2. I have 180 degree asymptote, it may terminates on infinite. तो एक रूट लोकस ब्रांच हो गया आपका. What about second and third? So second branch, एक ब्रांच ओरिजिनेट होगी at k is equal to 0 at -1 plus j. Second branch, third branch ओरिजिनेट होगी at k is equal to 0 at -1 minus j. लेकिन अभी ब्रांच की डायरेक्शन कैसी रहेंगी? फॉर दैट पर्पज वी हैव डिटरमाइन द एंगल ऑफ डिपार्चर. Okay, and what is the angle of departure for -1 plus j? For -1 plus j we have plus 45. Okay, okay. One small mistake I have made while calculating this phi d. Okay, so please recorrect it. I forgot it. Only small change will be there. So here we are determining phi d. So 180 minus phi. So it is summation of phi p minus summation of phi z. Okay, so here in phi value, it is what is the angle? So one with respect to this pole, here I have left this pole but we have to consider this pole also while contributing the phi d with respect to this. Okay, so therefore here phi p1 is the angle contributed by one pole at origin. So this I can consider it as phi p1 plus, and phi p2 is the angle contributed due to this complex pole with respect to this pole. Okay, so therefore now you can recalculate it. So 180 minus, so what is the value of phi p1 we have already calculated. So this 90 degree, so I can write down here phi p1 90 plus this tan inverse of 1 by 1, tan inverse of 1 by 1. Okay, plus what is phi p2. Okay, so phi p2 is what? Now we have connected this pole here. We are going to join this pole to this pole also. Okay, so with the help of solid line, you can join this pole to here. This pole we have joined to this. This pole also we have joined to this. Okay, so that is the first method. Okay, so therefore, what is the angle contributed with respect to this? So this angle is 90 degree. So therefore, here it is again plus 90. Okay, so this 90 plus tan inverse of 1 by 1, so it will be 180 minus 135 plus 90. Okay, so now you can recalculate it. So how much it is? So in this we have to calculate it. So 180 minus 135 plus 90. So it could be minus 45. So phi d could be minus 45. So phi d is minus 45. This is for minus 1 plus j, and for minus 1 minus j, it could be plus 45. So now it could be correct one. Okay, so please make this change. Then now how to start the root locus branch at minus 1 plus j. So the angle of departure we have got minus 45. तो माइनस 45 ड्रॉ करने के लिए क्या करना है आपको, ये जो भी पोल है ओके इसको एक पैरेलल लाइन अटैच करनी है. ओके, फेंट लाइन. तो दिस विल बी योर रेफरेंस एक्सिस. ओके, तो अभी रेफरेंस एक्सिस से आपको एंगल मेजर करना है माइनस 45. सो माइनस एंगल मींस इट इज क्लॉकवाइज मेजरमेंट फ्रॉम द रेफरेंस. सो रेफरेंस से क्लॉकवाइज में 45 डिग्री पे ऊपर आपको एक लाइन मार देनी है. ओके, सो रेफरेंस से clockwise direction as angle is negative, so therefore you just draw one faint line. So now let's say this angle is your 45 degree. Okay, so this line we have drawn with respect to this reference line. Okay, so now and similarly for other pole also, this will be your reference line, and for this pole the value of phi d is plus 45. So plus angle means anti-clockwise direction. So you can measure with respect to reference in anti-clockwise direction. So again you can draw a faint line having the angle of 45 degrees. So this is plus 45, this could be minus 45. Okay, so here we have drawn a phi d. Okay, then you can start with your root locus branch. So root locus branch always start at k is equal to 0. Okay, so up to certain distance you can draw your root locus branches. So here is the angle of 45 degree. Then we have already determined intersection of root locus with imaginary axis. तो वो intersect हो रहा है आपका what is the imaginary point, that is plus j 1.414. So at this point here is minus 1, so 1.4 somewhere here. So here is your minus 1, so somewhere here j 1.414 minus j 1.414. So at this point your root locus branches are intersecting with the imaginary axis. Okay, and then you just take small part through this 45 degree angle and then change your direction of root locus branch like. So this is your root locus branch like this, and at this value of k, so similarly here the root locus may start at k is equal to 0 like this, and after that I may change the path to like. So these are your root locus branches. Okay, and at this value, the value of k marginal is 4. Here k is equal to 0, k marginal is equal to 4. So that means for system to be stable, the value of k to be greater than 0 and less than 4. And beyond 4, when the value of k exceeds beyond 4, your root locus branches may move in the right hand side of the S plane and system become unstable. So this is the give the figure name for complete root locus of given problem. Do you have any doubt in this? We can take one more problem. So let's change the root locus for the given system. The open loop transfer function g of s into h of s k into s plus 5 upon uh, s square plus sorry not s square plus 4s plus 20. Okay, so write down step number 1. Find the number of poles and zeros. Tell me the number of poles and number of zeros.
Two poles and 1 0.
P is equal to 2 and Z is equal to 1. Correct? Okay. So again, which condition we are getting? So P is greater than Z. So when P greater than Z, what about the number of branches? So capital N is equal to P. Okay. So N is equal to P. So that means number of branches are 2. Okay. So that means actually two poles and 1 0. That means okay. So N is equal to P is equal to 2. Okay. Then which are the roots of your pole? Here is the complex pole we have considered s square plus 4s plus 20. What are the roots of this equation? So these are the complex pole. So s1 will be given to you minus 2 plus j4. You can calculate it on calci also. S2 is equal to minus 2 minus j4. These are the pair of complex poles and 1 0 at Here Z1 you are getting at S is equal to -5. So this could be your Z1. Okay. So this is regarding the basic information we have obtained from the open loop transfer function. Then second step, existence of root locus with real axis. Okay, sketch the rough sketch of your sigma j omega. Here is minus infinity. So -2 plus j4. So let's say here is my one complex pole. This point is -2. This could be j4. This could be j4 minus j4. This is plus. Okay. So pole हो गए 1 0. So 0 is located at -5. So let's say the symbolic representation of 0 is dot and small circle. So this could be at -5. So this would be my 0. So this is the pole 0 plot location. Then show the path of existence of root locus and non-root locus along the real axis. Please do this. So while doing this, what we are considering, जो भी पहला पोल या जीरो होगा रियल एक्सिस के ऊपर उसको सेक्शन डिवाइड किया. तो दिस इज माय फर्स्ट सेक्शन.
क्या है पता है बड़ी मम्मी को तो जनता पर मान पता है गलत वो बताएगा. अपने सब लोग
So for this section 1, what is the addition of p plus z? Whether it is odd or even. For this section, अभी ये s is equal to -5 यहाँ पर अगर किया तो ये 0 निकल जाएगा. इसके आगे कुछ है ही नहीं है. तो p plus z is 0. Okay, so therefore, which is neither odd neither even. So therefore, this is not a part of root locus. Okay, so therefore ये जो भी सेक्शन रहेगा. अभी यहाँ पर देखो, while calculating p plus z, do not consider the complex poles. You have to consider the p plus z along only real axis. Okay, so do not consider the complex pair of poles or zeros while calculating p plus z. यहाँ पर p plus z आ जाएगा 0. Therefore, this section is not a part of root locus. So this is NRL. So ये लाइन के ऊपर आप up to this s is equal to -5 इसको लिख लीजिए NRL. Then beyond -5 I can consider the section at -infinity. So -infinity for this section, what is the value of p plus z? So p plus z is 1. So that is odd. So therefore, the point beyond -5, you just make it dark beyond -5. So this is the part of root locus. Okay. So ये हो गया आपका existence of root locus with the imaginary axis. काम होतं ते चालू क्लासमध्ये मुद्दाम डिस्टर्ब नाही केला. हे सब्जेक्ट आणि सब्जेक्ट ओके. एकच सब्जेक्ट होता ना. Okay, so second step you have completed. Then what will be the next step? Write down next step. Number of asymptotes. Write down the formula. Theta is twice q plus 1 into 180 by 2. Sorry, 180 upon p minus z. So q varies from 0 up to p minus z minus 1. So what is the range of q? 0 up to number of poles are 2. 0 is 1. So 2 minus 1 minus 1. So 2 minus 2 is 0. So only q is equal to 0. So that means only one angle of asymptotes will be there. So theta is equal to, when q is equal to 0, so it could be 180 by p minus z. P is 2, z is 1. So theta is 180. So here in this case, the theta is 180. Okay. So angle of asymptotes, one asymptote's angle will be there, and its angle is theta 1, that is equal to 180. Okay. Then next step, centroid. So tell me the value of centroid. Yes. What is the value of sigma? So this is a unique problem. Okay, so here as only one asymptote will be there. So when there is a existence of only one asymptote, so at that time you can directly write down the node. There is no need of the centroid point. So please remember this. We just write down the node as there is only one branch approaching to infinity, hence one asymptote is present or exit. Therefore centroid not required. So this is the case only in case of one asymptote, and that too along 180 degrees. So in that case, the centroid calculation is not required. And next step, go for next step. तो नेक्स्ट स्टेप होगा आपका एग्जिस्टेंस ऑफ ब्रेकिंग पॉइंट Okay, whether it is breakaway or whether it is breaking, that we will decide later. Okay, so for determining breaking point, what is the condition? dk by ds must be equated to 0. So first of all, find the help of transfer function. You can find the characteristic equation 1 plus g of s into h of s. This is equal to 0. So 1 plus here is k into s plus 5 upon s square plus 4s plus 20, which is equal to 0. You can simplify this. So I have already simplified it. Okay. So it is s square plus 4s plus 20 plus k into s plus 5, which is equal to 0. Okay. So here we'll get the function. K is a function of s. So k is equal to, you will get minus of s square plus 4s plus 20 divided by s plus 5. Okay, so k is a function of f of s. So now obtain the dk by ds. So differentiate this k with respect to s. So obtain dk by ds. So dk by ds equal to which rule is applicable here? That is u by v rule is applicable. Okay, so v into u dash minus u into v dash divided by v square. Okay, so u by v rule you can apply in order to get dk by ds. Okay, so you will get like this: s plus 5 v as it is into u derivative, that is s square plus 4s plus 20, so that is twice s plus 4, twice s plus 4 minus v as it is, u as it is, s square plus 4s plus 20 into v dash derivative, so it is 1 divided by v square, so s plus 5 whole square. So this could be dk by ds. So simplify this and find dk by ds. So please simplify it. So after simplifying, you will get s square plus 10s, which is equal to 0. So find the roots of this equation. So here you are getting two roots at s is equal to 0 and s is equal to minus 10. These are the two breaking point. Breaking point we are getting s is equal to 0 and s is equal to 10. So which point is valid one? So that we are going to also determine whether s is equal to 0 or s is equal to minus 10 is valid breaking point or breakaway point. Okay, so if you see the structure of pole zero plot, so it will be clear to you. Okay, so s is equal to minus 10 is the valid breaking point. Okay, so that we will see while sketching the root locus. I can explain it. Okay, so this is our step. Then next step, step 6, intersection of root locus with imaginary axis. Please do it and tell me the value of S at which your root locus branches are intersecting with imaginary axis. Please do this. Whether your root locus branches are intersecting with imaginary axis or not, how to verify it. So here this is the equation we have, characteristic equation, that is s square plus 4s plus 20 plus as plus 5k, which is equal to 0. Okay, so you can simplify this equation. So s square plus this s term, you can take s term common. So it could be k plus 4 into s plus a constant है. Okay, so constant term मिल जाएगा आपको 20 plus 5k, which is equal to 0. So this is your required expression. Prepare a root array s square s and s raised to 0. Alternate coefficient, s square coefficient is 1. So after 1, it is 20 plus 5k. 20 plus 5k. Second row elements are k plus 4 and 0. So what is the element corresponding to 0? K plus 4 into this 0 divided by this. So that means it could be 20 plus 5k. So this is your root array. Okay. So find the value of k marginal. So this is the row corresponding to 0 for k to be greater than 0. So consider this equation as auxiliary equation. Then find the value of k marginal. So corresponding to 0th row, we will get k marginal. So k to be greater than equal to 0. So therefore, k plus 4 must be equal to 0. Okay, so therefore, here we will get k marginal equal to minus 4. So what is the change you have noticed here? As our k marginal is negative, so therefore we just note down here. Okay, so when k marginal is negative, that means our root locus branches never intersect imaginary axis. Okay, so therefore there is no need to calculate intersection with imaginary. Okay, so जिस केस में आपको k marginal negative मिलेगा, that means our root locus branches never intersecting with the imaginary. Okay, then the last step, very important, that is angle of departure. Write down the last step, angle of departure. phi d. Okay, so write down the formula. Phi d is 180 minus phi, or 180 minus summation of phi p minus summation of phi z. So for that purpose, we first draw a locus of pole zero plot, sigma j omega. So how many poles are there in the given problem? That is 2 pole and 1 0. So one pair of complex pole, its value is J4. Here is minus J4. This is minus 2. And one pole, 1 0 is located at minus 5. This is 1 0 at minus 5. S is equal to minus 5. So this is our location of pole cell 0. Okay. Now we have to determine phi d. Okay. So what will be the first step? First step is that we are going to determine the ID for this pole under consideration. Okay, so write down ID we are determining for minus 2 plus J4. For this pole we are going to determine. Therefore, you just join this pole with respect to all other poles. Okay, so therefore I have joined this pole to this 0, join this pole to this pole. So how many angles are contributed by this pole with respect to other poles? There are two angles. First angle is this and second angle is this. Okay, then calculate phi d. Okay, so write down the formula of phi d is equal to 180 minus summation of phi p. So phi p से जो भी हो रहा है, I can consider this is phi p1. So I will give the name to this phi p1 and I will give this name to phi z1. So phi p1 minus phi z. Okay, so 180 minus, what is the value of phi p1? Can you tell me the value of phi p1? Yes, phi p1 कितना है? Yes, Preeti. Aniket, phi p1 कितना आएगा? This angle with respect to this. So this with respect to reference axis is phi p1. So it could be 90 degree minus phi z1. This angle, tell me the value of this angle. Phi z1. So how will you determine phi z1 from this pole zero plot? What is this length? This is minus 2 minus 5. So it could be 3. And this length or this length. So this could be 4. This total length is 4 up to this point. Okay, so what is this? Apply the trigonometry. So this angle is nothing but tan inverse of 4 by 3. So phi z1 is nothing but tan inverse of 4 by 3, and the value of tan 4 by 3 is tan inverse of 4 by 3 is 53.13. Therefore, it is write down here tan inverse of 4 by 3. Okay, so therefore it is 180 minus 90 minus 53.13. So tell me the value of phi d. So the calculation, so it could be plus 143.1. So this is for minus 2 plus j4, and id is equal to minus 143.1 for minus 2 minus j4. So here we finish with all the steps. Now we can sketch the root locus. One zero is located at s is equal to minus 5, one complex pole. So this could be at minus 2, minus j4 plus j4. Okay, then part of root locus and non-root locus. So this is the part of NRL, and beyond this would be a part of root locus. So you can consider this point here. Here is s is equal to minus 5. So this section is a part of root locus. This is non-root locus. Okay. So after that, angle of asymptotes, we are getting only one. So one pole can terminate on infinity. Okay, so that we will see. So first of all, we mark the angle of departure. Okay, so for this pole, draw the reference line, and for minus 1 j4, it is 143.1. So that means plus angle. So here is 180, here is 90. So somewhere here like this, you just take the measurement. So this is the angle ID 143.1, that is ID, that is plus. Okay, then similarly for this pole, this is reference, and we want negative angle. So this is 90, 180, so somewhere here. So this is the line corresponding. So this total angle ID is equal to minus 143.1. Okay, so your first root locus branch originating at a is equal to 0, like this, like this. Again at this pole, a is equal to 0, like this, like this. You just take a short distance and then turn. Okay, then where these two branches are meeting together, so breaking point. So we have find the breaking point. Okay, either at s is equal to 0 or s is equal to minus 10. So s is equal to 0, which that point is lie under non-root locus part, So therefore, at s is equal to -10, so this will be your breaking point. S is equal to -10 is valid on root locus. So therefore, at this point, these two branches are meet together. So therefore, आपको यहाँ से branch draw करना है like this way, and you have to terminate here. So this first root locus branch are meeting over here. Okay, then this second root locus branch is also meeting over here. Okay, so therefore this is the existence of, इसको बोल सकते हैं break in point. At this point, these two branches are meet together, and at k is equal to the value of k is equal to 10. Sorry, value of k is 16 at this point. Okay, k is 16. So when it is exceed beyond 16, so one branch may terminate via this path to this open loop 0, and second path, एक जो भी branch रहेगी, it may terminating on infinity. So here via 180-degree angle of asymptote, it may terminate on infinity, and yet one branch is terminating at. So this is the figure for root locus of given problem. So in this way, you can sketch a root locus. So root locus is a very interesting point. So as many as example you are solving, you are getting a new clue. Okay, so you just do the practice of it. Okay, so we finish with this unit 4. So in the next lecture, we can start with unit 5. So today we stop here. So if you have any doubt while solving the problems based on root locus, you can contact me.